Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video, I'm going to create one networking project for college students. This is a user demand video. Some of my subscribers were requesting me to make one video on networking project. So today in this video, I'm going to set up and configure a cool networking project in Packet Tracer. If you don't know what is Packet Tracer, then Packet Tracer is a very simple simulation software which you can download from Google and you can install it in your system. Like you are installing any software, you can install Packet Tracer also. This is my Packet Tracer. Here you can see I'm going to design network in this workspace, and after that we'll configure that, right? So if you don't have Packet Tracer, simply you can browse Packet Tracer, name of this software in Google, say Packet Tracer download. You will get lots of link to download it. You can download any version and then you can install it. Once you will install it, you will get this interface, right? And here you can design the network. I'm going to show you how you can design the network, don't worry. And guys, for this networking project, I'm going to use 2 routers, layer 3 devices, 2 multi-layer switches, layer 3 switch, layer 3 capable, and 4 access layer switches, layer 2 switches. I'm going to use 8 PCs and 2 servers, right? So these devices are available in Packet Tracer, right? If you will see here in the left bottom, so there are some devices like the networking devices, then AND devices. Under AND devices you will get PC, server, printer, IP phone, voice over IP, TV, tablet, mobile phone, right? Many other devices are there. In networking devices, you can see we have routers, we have switches, we have hub, we have wireless devices, we have firewall, right? And then we have cable here, right, to connect devices together. Fine. So we'll use 2 routers, 2 multi-layer switches, 4 access layer switches, 8 PCs and 2 servers to design the network. Now if I will talk about the configuration part, so guys, this network, this project is very common, right? Like in most of the college, teachers are also providing similar project to the student, right? So if I will talk about the configuration part, so in configuration part we are going to configure VLAN and OSPF routing protocol for connectivity between multiple routers. So as I have 2 routers, how I will configure the routing? With the help of OSPF, and with the help of VLAN we are going to separate the traffic, or you can say department. Okay, so if you are a beginner in the networking industry, or if you need guidance for the networking project, then watch this video till the end, because in this video, as I told you, I am going to create, design, connect networking devices and configure the network. After that, we'll verify the connectivity as well, right? So I will show you how to create VLAN, how to configure OSPF protocol for the routing between multiple routers, how devices are going to communicate with each other, and then in the last we are going to verify the connectivity. So what you will learn in this video, you are going to learn how to configure VLAN, how to configure routing between VLANs, how to configure routing between routers as well with the help of OSPF, routing between routers, right? How to create, you can say SVI here, SVI for the inter-VLAN routing, and OSPF for the dynamic routing protocol, and then testing, how to test the network connectivity, right? Like if there is server, so we'll do one thing, we'll create some services on server, and after that we'll try to access those services from this PC. So now guys, without wasting our time, let's begin. Let me take you here to my packet tracer. Okay, first of all, let me give you some basic overview of this packet tracer. So see, this is the main dashboard view of this is, you can say, my interface. There are two options in the top. You can see logical and physical. So even you can see the physical connectivity and devices here also in packet tracer. After that, simulation option is there and real time option is there. In the right bottom you can see two options, real time and simulation. So if you want to see the packet data, you can use simulation mode, right? Otherwise you will use real time mode for your lab configuration, for your network designing and configuration. Then in the left bottom we have networking devices. So as I told you, I need two routers, right, for this project. So I am going to drag and drop two routers here, R1 and R1. Let me rename it, say R1 and R2, router 1 and router 2. Then guys, I need two multi-layer switch here. So I am going to drag and drop to multi-layer switch now. In the networking section, click on switches, and in switches you can see we have two multiple switches, like these are the access layer switches, access layer switch, and this is distribution layer switch. So I am going to use distribution layer switch here. Let me name it to D switch 1, distribution layer switch 1. I am going to use one more distribution layer switch here. So let me say D switch 2, distribution layer switch 2. After that, access layer switches. How many access layer switches? I am going to use 4 access layer switches. We'll discuss about the connectivity also, don't worry, how we are going to connect these devices and which cable I will use for connectivity. First, try to understand the designing part. After that, we'll see the configuration part. After watching this video, you will be able to design similar types of project. Even you can design different project as well, right? And if you need any other like project, networking project, you can let me know in the comment section. Definitely I will make one video on that also. Now I need 4 access layer switches. So 1, 2, 3 and 4. So let me give name to this switch is A switch 1, means access layer switch 1. Here A switch 2, access layer switch 2. Here A switch 3 and A switch 4, access layer switch 4. Done. Now guys, I need some PCs. How many PCs? 8 PCs and 2 servers. Done. So let me drag and draw 8 PC here. 1, 2, 3, 4, 5, 6, 7 and 8. Right? I can rename it to PC 1. So I have dragged 8 PCs. I need 2 servers. So server 1, server 2. Let me rename it to S1, server 1 and S2, server 2, let's say. Done. See guys, why we have access layer switches here? We have access layer switches to connect end devices together, like these PCs and server. How we can connect these PCs and server together? With the help of these access layer switches. These are my end devices. You can say these are the PCs of employees and these are the servers in your company, right? Like here you can host the application, here you can host the website, you can configure mail server, you can configure FTP server, TFTP server, syslog server, right? Any service we can run over here on these servers. So before starting the connectivity of these devices, let's understand the purpose for which type of company we are going to design this network. So guys, let's suppose for an example, you are going to create a network for a company with some departments, like we can say 4 departments are there, or 3 department, 5 department, 10 department, multiple department can be there. Let's say I have 4 departments. Department 1 is sales department. We have some PCs for sales department, like sales employees have some PCs. Then I have marketing team, so marketing people have some PCs. Then IT people are there, so some PCs, IT people PCs are there, right? And then we can say admin department, there are some admin PCs, right? So these are the 4 departments. And how you are separating department means different traffic in network with the help of VLAN, right? So I will assign one VLAN for sales department, one VLAN for marketing department, one VLAN for IT department, and one VLAN for admin department. So let's say here for sales department I have assigned VLAN number 10. VLAN 10. For marketing department, guys, I have assigned VLAN, let's say 20. For IT department I have assigned VLAN 30. This is just an example. You can use different VLAN as well. And for admin department I have assigned VLAN, let's say 40. Now you know all the departments need IP addresses, correct? So I need network ID means IP addresses for each department. So let's say network ID for sales department is 10.1.1.0/24, or I can use any other 192.168. Let's say 10.0/24. For marketing department I'm going to use subnet 192.168.20.0/24. And for IT department I'm going to use subnet 192.168.30.0/24. And for admin department, where I have some servers as well, I'm going to use 192.168.40.0/24. You can use any subnets, right? But for each department you need IP addresses. And you can see in this subnet we have total 254 IP addresses, right? Out of 254 IP addresses, I will use one IP address for default gateway, and rest all IP address can be assigned to PCs. So let's suppose last IP address from the subnet is default gateway IP address, okay? And IP address from .1 to 253 we can assign to PCs, right? Now let's suppose in sales department we have some PCs, so total we have 8 PC, right? Let me do one thing. Let me put PC 1 and PC5 in sales department. Like this you can have multiple PCs also, right? This is just a project, so I am taking 2 PCs in each department. For marketing department, let's say I am going to put PC2 and PC6. In IT department I am going to put, let's say, server 1 means S1 and PC3. And in the admin department I am going to put server 2 S2 and PC4, last PC4. So this is my requirement. This is my requirement for the network. This is the reason why I am designing the network. And guys, after designing and configuration, these all departments users should be able to communicate with each other. After the configuration, these all departments should be able to communicate with each other. Here I can put the requirement like this. This is my requirement. Guys, this is a perfect networking project for colleges, because here we are going to create multi-layer network with VLAN and OSPF routing. In the real-time network also, VLAN is used for the segmentation, for dividing large network into a smaller network. So VLAN segmentation is very important for real-time network also. And for the layer 3 routing, we are using OSPF in most of the time, right? So that's why I will suggest you to create topology design like this for your college project, right? Now, without wasting time, let's connect these all devices together. So guys, as you know, to connect networking devices, we have two way. We can connect networking devices wirelessly also, and through wire also, right? And today in this video, we are going to connect all networking devices through wired, and we have multiple types of wired, like Ethernet, like fiber cable, and under Ethernet again we have multiple types of cable, crossover cable, straight through cable. And if you don't have idea about the cable, then see under the cable section we have one automatic option. What it's saying, automatically choose connection type, right? If you don't know which cable I should use to connect PC to switch, no worry, you can use this cable, which is the automatic choose connection type. So let me select it, and let's connect PC1 to access their switch, PC1 to access their switch, PC2 to access their switch, PC3 to also, let's say, access their switch 1, PC4 switch 2, like this we can connect any PC to any switch. And with the help of VLAN, we'll put these devices in correct department. Like you know, PC1 should be in which department? PC1 is sales department PC. So we will put that in VLAN 10. Now you can arrange it so that your port should be visible, because for the VLAN configuration, port should be visible. You need port information, the interface information. F0/0 is connected with PC6 of switch 3, PC3. Done. Now you can see all the ports are visible. Now guys, we are going to connect these access layer switches to distribution layer. See, now all my end devices, means client PCs, are connected to network, but now they cannot communicate with each other. The reason, these switches are not connected with each other. So we are going to connect access layer switches to distribution layer. See, the purpose of all access layer switches is to connect end devices, your PCs, servers, printer, IoT devices, mobile devices, right? So to connect end devices, we are using access layer switch. Now to distribute traffic between access layer switches, we have what? Distribution layer, right? Like let's say these routers are connected with internet, and if someone from the internet want to access this server, how they will access? They will forward traffic to this router will forward traffic to switch, and on the basis of department or VLAN, this switch is going to forward traffic to access layer switches, to lower layer switch, right? So means whenever your user will generate traffic for internet, traffic will first reach to access layer switch, then distribution layer switch, then router core layer, and then router will forward it to, let's say, internet. In the same way, when reply will come, traffic from internet to the PCs will, first device is your router core at core layer, then router to distribution layer switch, and distribution layer switch is going to forward it to access layer. So what we are saying? We are saying this is a access layer. This is multi-layer architecture. This is distribution layer, and this is core layer. At core layer, we have high-end devices, high configuration routers, which is responsible for internal and external routing, right? Then at distribution layer, we have multi-layer switches, and at access layer, we have access layer switches, right? So now let's understand how we are going to connect all access layer switches to distribution layer. So guys, we'll connect all access layer switches to both distribution layer switch, right? Like switch 1 to distribution layer switch 1 also, and to distribution layer switch 2 also. So here we have redundancy as well. Like if switch 1 will goes down, distribution layer switch 1 will goes down, no problem. Then also end devices can access internet or can communicate with each other via distribution layer switch 2, D switch. distribution layer switch 2. So that's why here we have two distribution layer switch. Then switch 2, again I will connect switch 2 to both distribution layer switch. Then switch 3, again I will connect switch 3 to both distribution layer switch, and switch 4 to both distribution layer switches. Correct. Now we are going to connect distribution layer switch to router, core router, like this, right? So this is your network design. At core layer and distribution layer you have two devices. So the benefit of using two devices over here is, see, we have redundancy. We can perform even load balancing between distribution layer switch 1 and distribution layer switch 2. If you want that two departments, sales department and marketing department, user should communicate through distribution layer switch 1, and IT department and admin department should communicate via distribution layer switch 2. So you can. Now everything depends on the configuration, how you are going to configure the network. Okay. So let's begin the configuration, guys. First of all, I am going to configure these distribution layer switches. Means I'm going to configure link between switches as trunk. So see, these are the switches, distribution layer switch and access layer switch. Both are switches. And if I will talk about the port of switch means these port. So guys, there are two types of switch port. One is access port and another one is trunk port. Access port is the port which carry traffic of single VLAN, and trunk port is the port which carry traffic of all VLAN, or you can say multiple VLAN, right? So like you can see, this port 0/1 is connected with PC1, and PC1 is in which VLAN? It is in VLAN 10. That means this port is going to carry traffic of VLAN 10 only, right? This port will not carry traffic of this port, this port. So this port should be the access port because it will carry traffic of single VLAN. But if I will talk about this port or this port, so guys, this port is going to carry traffic of this port also and this port also, means multiple VLAN, VLAN 10 also, 20 also, 30 also, maybe 40 also. So these port means link between switches should be the trunk link. So first of all, we are going to configure this link as trunk link. And to configure link as a trunk, we have a protocol called DTP. Dynamic trunking protocol. So we can form trunking between switches dynamically, or you can configure statically as well. Let me arrange it a bit better. Let me access distribution layer switch 1 first. Go to the configuration part. See, the device is off. So first of all, we need to turn on this device. And guys, to turn on this device, we have to provide power. Here you can see power is not there. Now, where I will find the power adapter? So guys, see here, AC power supply, right? We need to drag and draw this on my device. Even you can see, this is the logical diagram. If you want to see the physical diagram in real time, how you will insert these devices, you will insert these networking devices in rack. So if you will click on physical, and then here you will see your devices. You can see these are the PCs. All PCs and server are connected with networking rack, right? If I will click on networking rack, so you can see in rack, guys, we have lots of devices. Let me zoom it little more. Yes, you can see lots of networking devices are there. This is my router 1, router 2, router 1, router 2. Even you can click on the device to see the physical device, like how device looks like. This is your router. You can zoom it on. Now there are some empty slot. In the slot there are no card, right? So we can insert some card here, like this card. This card is not compatible with this slot, right? So according to the compatibility, we can add the slot here. We can add the card here, and after that, like you can see, so power is on. First of all, you have to turn off your router, and after that you can add the card. So 1, 2, 3, 4 and 5 slots are empty here on this router. We can insert the card to increase the port number of port. By default, see how many ports are there on this router. Only 2 port. One is fast Ethernet 0/0 and another one is fast Ethernet 0/1. I have already used one port, and one port is still free. If you need more port, you can insert the card here. to insert the card, simply you can turn off the device, and after that you can drag and drop the card like this card. This card is, you can see this module is not compatible, so you have to find the compatible module here, like this one. This one is compatible with this slot. After that I can turn it on. So see, here I have added the card, and here also in the rack also you are able to see the card. If I will remove it from here, also you can see from the rack also it removed. So this is networking rack. In the networking rack, on the top I have power supply, from where I can provide power to these devices. And guys, in the rack, see how many devices are there. I have two routers, R1, R2, and on router, see some few more things are there, like these are the access port and auxiliary port to access these devices. Then turn on and turn off button is there. After that the ports are there, fast ethernet 0/0 and 0/1. This is how router look likes. Then router 2. After that, distribution layer switch 1. This is distribution layer switch 1. You can zoom it on. Here also you can see some slots are empty, and in some slots we have card, right? Distribution layer switch 1, distribution layer switch 2. We have two distribution layer switch, and then I have access layer switches. So in access layer switches, you can see I have lots of ports. How many ports are there? 24. Means I can connect 24 devices to this switch, right? So one switch can connect up to 24 devices. So that's why we have multiple access layer switches to connect multiple and devices. And then all access layer switches are connected with, you can see yellow cable, to distribution layer switches from both distribution layer switches, and distribution layer switches are connected with routers. Even we can connect your distribution layer switch to router. I can add more cable for the redundancy. This is the physical view. And after that, on the table, you can see this is table. On the table we have some laptops, servers, and those devices are also connected with PCs. So these are the cable connected to PCs. Okay, this is physical view of your topology, because in real time we are not going to like install devices like this. We will install devices in rack. So I have one networking rack here. In the rack, first of all I am going to install router number 1, R1, then R2, then distribution layer switch 1, then distribution layer switch 2, then all access layer switches, and I am going to connect all access layer switches to both distribution layer and then distribution layer switch to routers like this. Even we can add one more cable here between this distribution layer switch and router, and one here like this, right? After that, there are only 2 ports on router, so you need more ports to connect this router to internet, because now you are going to connect this router to internet, which is not part of your project, but in real time you will connect your core layer to internet, right? So we can add the extra port with the help of card. We have free slot, we can add the card there in the free slot. So guys, let's turn on this device first. So to turn on, here I have AC power supply. Let me drag and draw here, right? Now you can see my device has power. Let me click on CLI, and you can see this device is now booting. So after some time I will have access of this device. In real time, how you will access this device? You will access this device through PC, right? You will have one, let's say you are network engineer, so this is your laptop. Now you are going to connect your laptop to console port of this switch here, and on your console port, see this is the console port, and now I can access this switch through my PC. Click on terminal and say OK. Now you can see here I have access of this switch. This is how you will access devices in real time. In packet tracer, simply we can click on device. And guys, the another option to access devices in real time is remotely. We can use protocol like Telnet and SSH to access the networking devices remotely. Now let's again click on this device to access, because in packet tracer you can access the device by clicking on device. And now here you can see I have access. First of all, I'm going to say no to this. It is asking for the initial configuration dialog, so I said no. Now I have access. of distribution layer switch. First command is enable command to enter in privilege mode. After that, configure terminal. See, these are the basic networking. If you don't know basic networking and looking for the training, you can visit my website or my YouTube channel. We are launching CCNA batch time to time every month, right? If you want to learn, you can enroll yourself for the CCNA course, and you can learn these all things like the configuration of devices, network designing in detail. By the way, I am going to show you step by step how to configure this network for your project. So after this video, you will be able to design and configure the project, but you will not have the detailed knowledge of this configuration, like how this configuration works, right? For that, definitely you have to learn it. Now I have access of this switch and I am in global configure mode where I can configure the device. Actually, there are three mode. User mode. This is the user mode. When you will access the device, you will get access in user mode where you can view the configuration, but you cannot perform the configuration, right? Then second mode is enable mode. Again, in this mode, we can view the configuration and we can perform some basic configuration, but not the main configuration. So we have third mode, that is global configure mode, where I will configure the device. In this mode, we can perform the configuration. Now this time I need to configure interfaces of router. So I am going to run command interface, and then guys, interface type. So what is the interface type? Gig. These are the gig interface, right? Giga Ethernet. So I can say gig, and then interface ID 1/0/1. Here you can see this port ID 1/0/1. So individually I can configure all the interfaces one by one, or I can select all the interfaces together. How many interfaces are there? Total 0/1 to 4, 0/4. 4 links are there. One is going to with access layer switch 1, 2, 3, 4, like this, right? So let me do one thing. Let me select all the port together. To select all the port together, I will run command interface, then range, then Giga Ethernet 1/0/1 to 4. Now I have selected these 4 ports. Whatever configuration I will perform here, that will be applied on these all ports. Now here I am going to configure trunk link with the help of DTP protocol. So I am going to say switch port mode. I am going to change the switch port mode. Switch port means port of switch, right? Say switch port mode and dynamic desirable, right? Once you will hit enter, these all interfaces will become trunk. Even you can verify that by running command show interface trunk, right? So you can see 0/1, 0/2, 3, 4, all these interfaces are trunk interface. We need to do same thing on distribution layer switch 2 also. Let me access this switch. Again, power. So let me provide AC power supply here, and now my device is booting. Yes, now booted. Say no to this. Enable config T interface range G 1/0/1 to 4 and switch port mode dynamic desirable, right? Now you can see all these ports are trunk ports. So interface trunk. These all interfaces are trunk interface. Done, guys. So I have configured the trunk. Even now you don't need to access layer switches to configure trunk. Automatically these access layer switch will configure their ports as trunk, because here I have used DTP protocol. So even you can verify it on access layer switch 1. On access layer switch 1, I am going to say so interface trunk. So you can see 0/1, 0/2, 0/1, 2, 3, 4. These all interfaces are configured as trunk here on access layer switch 1, but I will configure only 0/1 and 0/2 as trunk. These interfaces, sorry, not 1 and 2, 4 and 5. These 4 and 5, these two interfaces should be trunk, and these interfaces should be the access, right, for VLAN 10, 20, 30, 40. Okay. So now guys, now next thing is we need to create VLAN. right? VLAN 10, 20, 30, 40. Again, for to create VLAN, we have two options. I can create these all VLAN manually on all the switches one by one, or I can use a protocol called VTP protocol, right? VTP is a protocol. VTP stands for VLAN trunking protocol. It is used to propagate VLAN information, right? Like with the help of VTP, you can create VLAN on one switch. Let's say on this switch I will create the VLAN, and VTP protocol will propagate that VLAN to all the switches, right? To access layer switches as well as to distribution layer switch, right? So let me do this. Let me configure the VTP first here, and after that I will create VLAN. So to configure VTP, simply I need to say VTP domain name. VTP domain name is, let's say, Cisco. Done. So now you can see name is changed from null to Cisco. Now I am going to create VLAN 10 here, and name of VLAN 10 is, here you can see the name is sales. So I am going to say name sales, then exit, then VLAN 20, name of this VLAN is marketing, exit, then VLAN 30, and name of this VLAN is IT, exit, and then VLAN 40, name of this VLAN is admin, right? Done. Now you can verify the VLAN by running command show VLAN brief. And guys, here you can see we have these all VLAN 10, name sale, marketing, IT, and admin. There are no any interfaces in these VLAN. All the interface of switch belongs to VLAN 1, which is the default VLAN, right? Now let me do one thing. Let me verify the VLAN on other switch. Let me access their switch 1, and here I am going to check the VLAN is created or not. So VLAN brief. So you can see automatically VLAN is created on this switch, right? So with the help of VTP, actually now this switch is going to propagate VLAN information to all other switches, right? Even you can access distribution layer switch 2. So VLAN brief, and here also you can see we have VLAN 10, 20, 30, 40, right? On access layer switch 4, enable so VLAN brief. So here we have all the VLANs. Now guys, next thing is we are going to put PCs in correct VLAN. So you can see PC1 and PC5, in VLAN 10. These two PCs are in VLAN 10. So here is my PC1, and PC1 is connected with port, which port? 0/1 port of access layer switch 1. So let me access layer switch 1, and here I am going to say interface F 0/1 and switch port access VLAN 10. This command will put this interface in VLAN 10, right? After that guys, see PC2 0/2 interface F 0/2. PC2 is in which VLAN? PC2 is in VLAN 20. So I am going to say switch port access VLAN 20, exit, then interface F0/3. This interface switch port access VLAN. PC3 is in which VLAN? PC3 is in VLAN 30. So I am going to say VLAN 30 here. Then all done on switch number 1. On access layer switch 1, we have created the VLAN, and we have put the PCs in correct VLAN. So VLAN brief. Now you can see here PC1, still we don't have any interface in this VLAN. What happened? Let me troubleshoot it. So interface F0/1 switch port. This port is configured as trunk. So this is the issue. First of all, over here we have to configure these ports as access port. Interface range F0/1 to 3. I'm going to say switch port mode access. This is how manually we can configure access port. Now, so VLAN brief. Now you can see 0/1 port is in VLAN 10, 0/2 is in VLAN 20, and 0/3 is in VLAN 30. And which PC is connected on 0/3 port guys? PC3, which is a part of VLAN 30 only at IT department, right? So PC3 belongs to IT department, PC2 belongs to marketing department, and PC1 belongs to sales department. So that's why we have put it PC1 in VLAN 10, PC2 in VLAN 20, and PC3 in VLAN 30. Now let's do same thing on access layer switch 2 also. On access layer switch 2, you can see 0/1 port is connected with PC4, and PC4 is in which VLAN? PC4 is in VLAN 40, admin VLAN, right? So enable config T interface F0/1. I'm saying switch port mode access first. I've configured access port, and now I'm saying switch port access VLAN 40, because switch 4 is in VLAN 40, switch 4, right? Then F0/2 interface F0/2. Here I am saying switch port mode again access, and then switch port access VLAN. Which VLAN? It is VLAN PC5. PC5 is in which VLAN? PC5 is in VLAN 10. So let me say VLAN 10 here. Done. So VLAN brief. Here you can see I have 0/2 in this VLAN and 0/1 in admin VLAN, correct? Now let me take you to this switch, switch 3. On switch 3, guys, see first of all PC6. PC6 is connected on 0/1 interface. So interface F0/1, switch port mode access, and then switch port access VLAN. In which VLAN I am going to put PC6? PC6 is in VLAN 20. So VLAN 20. Then interface F0/2, switch port mode access, and switch port access VLAN PC7. PC7 is part of which VLAN? PC7 is not there. Let me do one thing. Let me put PC7 also in VLAN 40. PC7 also in VLAN 40. So here I am going to say this is access layer switch 2, VLAN 40, PC7. And then PC8. Let's say PC8 is in VLAN 10. Here I am going to add PC8. PC8. Done. So on access layer switch 3, interface F0/3, switch port mode access, and then switch port access VLAN 40. Sorry, 10. Done. Now last switch, switch 4. Config T interface F0/1, switch port mode access, and switch port access VLAN. Server 1 is in which VLAN? Server 1 is in VLAN 30. So 30. Exit interface F0/2, switch port access VLAN server 2. Server 2 is in VLAN 40. So VLAN 40, and switch port mode access. Done. We have configured all the PCs in appropriate VLAN and correct VLAN, right? So we are done with the VLAN configuration. We are done with the trunking configuration. Now guys, we can configure the IP addresses to these PCs. So let me do one thing. Let me configure one IP on PC1. PC1, I'm going to configure IP 192.168. See the subnet for PC1. PC1 is in VLAN 10. So subnet is 10.0/24. I'm going to use .1, right? Subnet mask 255.255.255.0, and default gateway IP address, last IP address 10.254. Then PC2 is a part of which VLAN? VLAN 20. So here I am going to configure 192.168.20.1, subnet mask 255.255.255.0, and gateway is 192.168.20.254. Like this, you can configure IP address on all the PCs. Let me configure IP on server 1. On server 1, server 1 is part of which VLAN? S1 VLAN 30. So 192.168.30.1 subnet mask 255.255.250 and gateway 192.168.30.254, right? Now we need to create SVI, right? SVI on distribution layer switches. For all the VLAN, I am going to create one virtual interface on these distribution layer switches. Let's access the switch and config t interface VLAN 10. On VLAN 10 interface, I am going to configure last IP address from the subnet 192.168.10.254.255.255.255.0. Interface VLAN 20 IP address 192.168.20.254.255.255.255.0. Exit interface VLAN 30 and IP address 192.168.30.254.255.255.255.0. Exit interface VLAN 40 IP address 192.168.40.1255 40.254 40.254 255.255.255.0. Done. I have created the SVI. So IP interface brief. You can see the IP on these VLANs interfaces, right? On all VLAN 10, 20, 30, 40 we have IP address. The status is up, line protocol is up. Now PC1, see, which is a part of VLAN 10, have IP address from the same subnet and the default gateway is also correct. So now PC1 can ping to their default gateway. Ping 192.168.1.254. This ping will work. Wait a minute. If ping will not work, then we'll troubleshoot it. We will troubleshoot it. That why ping is not working. But I think ping should work. So MAC address table 0/1 interface is leaving the MAC address correct. PC1 let me ping their own IP address. Sorry, there is some misconfiguration. Let me check the IP configuration. Sorry, 10.1. It's 10.1. I was pinging 1.1. Extremely sorry. Ping 10.254. And you can see ping is working. Means I am able to ping the gateway IP address. And guys, I can ping PC2 also, which is part of different VLAN. Ping 192.168.10.2. Sorry, 20.1. 20.1. Which is the IP address of PC2. This ping is not working. Let me first try to ping PC2 default gateway. Let me access PC2 and from PC2 I am going to ping their gateway. Ping 192.168.20.254. See, PC2 is able to ping their gateway IP address. Then why these two PCs are not able to communicate? These PCs should also communicate. Let me ping PC2 like VLAN 20 gateway. I'm able to ping PC2 gateway dot 1. IP is correct. 2.1, yes, 20.1. This is correct IP address. 254 correct. From PC2 I am going to ping gateway of PC1, ping 192.168.10.254. Yeah, I'm able to ping. Both PCs are able to ping their gateway and VLAN 20 gateway. So ping should work. Okay. On distribution layer switch, it might be possible by default routing is disabled. So I need to run one command, IP routing here. And after that we can try. And now you can see ping is working. From PC1 I am able to ping PC2. But guys, still there is some issue. See, the gateway IP address on the PC is IP address which is running on this switch, distribution layer switch 1. So what if this distribution layer switch 1 will goes down? Then there will be no reachability. These devices cannot communicate with each other. So what we can do, we can configure one HSRP protocol for the redundancy. For redundancy between distribution layer switch 1 and distribution layer switch 2. So what default gateway I have configured on PC? Last IP address from the subnet. Now on the distribution layer switch 1, I am going to configure .100 from all the subnet, like for VLAN 10, 192.168.10.100 to 20.100 for VLAN 20, 30.100 for VLAN 30 and 40.100 for VLAN 40. And on switch 2 I am going to configure .200. And by combining these two physical IP address, I will create one virtual IP address that will be .254, and that is the gateway IP address. So what will happen if this switch will goes down? Then PC will forward traffic towards switch 2. Right, one switch will be active and one switch will be standby. That is load balancing. If you want to learn the HSRP protocol, see, one video is available on my channel. You can search HSRP. You can search HSRP PM networking. HSRP PM networking. You can search this in YouTube. You will get my video. From there you can learn this protocol. Now I'm going to configure it. So guys, to configure here, first of all I need to change IP on all the interface. Say IP address 192.168.10.100, subnet mask 255.255.255.0. Then VLAN 20. On VLAN 20 interface, IP address is going to be 20.100. 20.100. On VLAN 30 interface, IP address is going to be 30.100. 30.100. And on VLAN 40 interface, IP address is going to be 40.100. 40.100. Done. Now show IP interface brief. You can see the IP on all the interfaces .100. Right, now distribution layer switch 2. For distribution layer, on distribution layer switch 2, I am going to configure IP .200 for the redundancy. Interface VLAN 10, IP address 192.168.10.200 255.255.255.0. Then guys, interface VLAN 20. Here IP address is going to be 20.200, and VLAN 30 IP address is going to be 30.100, sorry 200, and on VLAN 40 IP address is going to be 40.100. 40.100. Done. See, so IP interface brief. These are the IP. Now we are going to configure HSRP protocol on both switch. Let me access distribution layer switch 1 first. Here, to configure HSRP, you need to run one command. Again, you need to run this command on all virtual interface, on VLAN 10 also, 20 also, 30 also. So I can use interface range command. Then VLAN 10, VLAN 20 and VLAN 30 as well as VLAN 40. On these all interfaces I am going to configure HSRP protocol. So it's giving error. We cannot select run command like this. I have to do it individually on all interface. Interface VLAN 10. I am saying standby and then group number, let's say 10, and after that IP address. What IP address you want to configure? Virtual IP 192.168.10.100. 10.254, right? In the same way for VLAN 20, I am going to configure 20.254. For VLAN 30, I am going to configure 30.254 virtual IP address, and on VLAN 40, I am going to configure 40.254. Done. Now you can see this switch is the active switch for VLAN 10. VLAN 10 group number 10 state active. Done. For all the VLAN, soon this switch will become active switch. How to verify? You can see the log message. For VLAN 30, it's a standby. Now it's active, right? To verify it, we can run command show standby brief, right? So you can see for VLAN 10, 20, 30, 40, for all the VLAN, I have enabled HSRP protocol group number 10. Priority is default, which is 100, and this switch is the active switch. So if you want to configure this switch as primary switch, you can increase some priority. This is the default priority, and by default priority on both switches is going to be same. So next command that here I can run is interface VLAN 10. I can say priority standby number 10, priority 110, let's say, right? For VLAN 20 also, for VLAN 30 also, for VLAN 40 also. Done. For all the VLAN, I have increased the priority. Now if you will check, so standby brief, you can see priority over here is 110. So now switch 1 will be the active switch. So history, let me check, no command is not available. Now let me configure HSRP on switch 2. So guys, here we are not going to change the priority. Priority is going to be same because this switch is my backup switch. Interface VLAN 10. Here I am saying standby group number 10 and the IP 192.168.10.254. For VLAN 20 also IP 20.254. For VLAN 30 30.254, and for VLAN 40 40.254. You can also configure these things, even doesn't matter. See, if you all don't need the project, then also you can try it in Packet Tracer. It is free tool. You can download it from the Google, and after that you can practice. Now so standby brief. So you can see this switch is the standby switch for all the VLAN. This switch is the standby and group number is 10. For all the VLAN, this switch is the standby, and the virtual IP address is this one. Standby is the local switch. Here is the virtual IP address. What happened? There is some issue on VLAN 30 interface. I am getting error message 30. So standby brief here for VLAN 30 standby, this one correct. IP is 30.254. Let me check on switch 1 if there is some misconfiguration. So standby brief, okay. On this switch, see IP address is on switch 1, IP address of standby is fine. The virtual IP address is 254, correct. This switch is the active switch. It's correct here. What happened then on distribution layer switch 2? .254 is the virtual IP address. Active router IP address. So IP interface brief 30.200. VLAN 40 group number 10 active router virtual IP address. This one is different. 30.254 is different to the locally configured address. For all the group, I'm getting this error message here. 254 virtual IP address. Their own IP address is, it might be possible this is because of simulation software. We can check it. Interface VLAN 10 shutdown. Standby group number 10 IP 192.168.10.254. No set. Exit. Interface VLAN 20. So standby active router IP address is .100. So guys, maybe that was the issue because of software only, right? Sometime it might be possible you can get these types of issue, but the configuration was correct and now you can see it's working. Again, I started getting this message. So I think it's not working here properly. In the simulation, you are getting the error. You can do one thing, you can try another distribution layer switch here. No interface VLAN 10, I am saying. No interface, I am saying VLAN 20. No interface, I am saying VLAN 30. And no interface, I am saying VLAN 40. So I have removed it. For now, you can try it on another switch, right? It will work, or maybe in your scenario it will not happen. See, there are two distribution layer switch here. One is this one, another one is this one. So you can try this one. Okay, for now I am going to delete it. Okay, now let me do one thing. Now let's configure OSPF between router and distribution layer switch. So guys, here also we need one subnet between router and distribution layer switch. Let me use 10.1.1.0/24 here and 10.1.2.0/24 here, right? Any subnet you can use between router and distribution layer switch. So here I am going to configure .1 interface G1/0/5. This interface, first of all, this is layer 2 switch. All ports of layer 3 switch behave like layer 2. First of all, I have to configure this switch as layer 3. So to convert layer 2 port into layer 2 port into layer 3 port, you can run command no switch port, right? No switch port, and after that say IP address 10.1.1.1 255.255.255.0 and no set. That's it. After that, guys, to enable OSPF, we can run command router OSPF 1 and then network command. With the help of network command, we are going to advertise all the subnet in OSPF 192.168.10.0 wildcard mask 0.0.255, and I am going to put it in area 0. In the same way, I will advertise 192.168.20.0 also, 30.0 also, and 40.0 also, right? After that 10.1.1.0 0.0.0.255 area 0. Now you can check OSPF is enabled on how many interfaces. So IP OSPF interface brief, and you can see here OSPF is enabled on all the interfaces, right? On all virtual interface as well as on G0 by 2. Sorry, it should be on 0 by 5. It should be on 0 by 5, not on 0 by 2. So IP interface brief. So guys, by mistaken I have configured IP on 0/2 interface. Here you can see, let me correct it. Now it's stuck, it will take some time. Till then let me do one thing, let me configure distribution layer switch 2. After that I will come on distribution layer switch again. So interface G1 by 0 by 5. Here say no set and IP address. See, I'm not able to run IP address command because this is layer 2 port. So first say no switch port and then IP address 10.1.2.1 255.255.255.0, right? Then OSPF, so router OSPF process ID 1. No, routing is disabled, so say IP routing. Now router OSPF 1 and network 192.168.10.0 area 0. In the same way I'm going to advertise 20 also, 30 also and 40 also, right? And network 10.1.2.0 area 0. Here also we can verify OSPF enabled interface. So IP OSPF interface brief. So IP OSPF interface brief. OSPF is not enabled because guys I have disabled the virtual interface SVIs from this switch. Let me create the SVI again. Interface VLAN 10 IP address 192.168.10.200 and let me say standby. Let me try to configure standby also once again 10.254. Then VLAN 20 IP for VLAN 20 is going to be 192.168.20.200 and standby IP address is going to be 20.254. Earlier routing was not enabled, so that's why I'm trying again 0. Now you can see we have OSPF neighborship between distribution layer switch 1 and distribution layer switch 2. I am on VLAN 30 interface, so here IP address is going to be 192.168.30.200 and standby 30.254. and after that VLAN 40 and on VLAN 40 IP address is going to be 40.200 and standby IP 40.254. Now so IP OSPF interface brief, you can see OSPF is enabled on all interfaces. Why OSPF is not enabled on 0 by 5 interface? G1/0/5. So IP interface brief, let me check 0 by 5. Here the IP is correct. Line protocol of this interface is down. This is the reason, right? Again I am getting this error, you can ignore it. Now let me take you to again this distribution layer switch 1. It might be possible in your scenario you will not get error. So IP OSPF neighbor. So we have OSPF neighborship as well between distribution layer switch 1 and distribution layer switch 2. So IP OSPF interface brief. OSPF is enabled on 0/2 interface. Let me correct it. Interface G1/2. First of all, I am going to say switch port to make this port as switch port. No IP address. Even we cannot run IP address command now because this port is switch port, and switch port mode dynamic desirable. Again, I have configured the trunk link, and let me take you to 0/5 G1/0/5, which is connected with your router. Here I am saying no switch port and IP address 10.1.1.1 255.255.255.0 and no set. Done. So IP OSPF interface brief. Now you can see OSPF is enabled on all the VLAN interfaces, as well as soon OSPF will enable on 0/5 also, because guys, line protocol of 0/5 is down. So IP interface brief, you can see 0/5 line protocol is down because by default router interfaces are down. So let me configure router now. R1 on router 1, no interface config T, interface F0/0 no set, and IP address 10.1.1.2 255.255.255.0. Exit router OSPF 1 and network 10.1.1.0 wildcard mask 0.0.0.255 area 0. Now soon we will have OSPF neighborship between this router and distribution layer switch 1. So IP OSPF neighbor. So this is in two-way state. Soon OSPF neighborship will come in full state. And now here you can check the OSPF enabled interfaces. So IP OSPF interface brief, you can see on G0/5 OSPF is enabled. So IP OSPF neighbor in access start state neighborship is here. Just wait for some time. After that neighborship will come in full state. Till then, let me configure router 2. On router number 2, again say no, enable config T, interface F0/0 no set, and IP address 10.1.2.2 255.255.255.0. Exit router OSPF 1 and network 10.1.2.0 0.0.255 and area 0. Again we will have OSPF neighborship here between router 2 and distribution layer switch 2 also. So IP OSPF interface brief, you can see OSPF is enabled on F0/0, and so IP OSPF neighborship is in two-way state. Now let's verify the OSPF neighborship between router 1 and distribution layer switch 1. So here even you can see the log message, right? So I have one log message here for the OSPF neighborship. And now guys, if you will check the routing table of this router, so IP route OSPF, so you can see router is learning all the internal prefixes 192.168.10.0 20.0 30.0 40.0, right? And you can check the PC is able to ping router or not. So ping, and the IP address of R1 is 10.1.1.2, and you can see ping is working. Means PC is able to ping router as well, right? Now I can connect this router to internet from here. Again here also we have neighborship on router number 2, router 2 routing table. So IP route OSPF, so router 2 is also learning these all prefixes via distribution layer switch 2. Okay, so now guys, all the end devices are able to communicate with each other and they can access internet also if you will integrate the internet on router 1 and router 2. In any another video I will do one thing, I can create part 2 of this where I will connect router 1 to internet and I will show you how these users can access internet. For now, let me do one thing on the server. Let me create one website. So guys, server IP address is 30.1 and this server is in which VLAN? It is in VLAN 30. Okay, so go to services. In services, HTTP service is by default, you can see enable. We can edit the code, like here we can say welcome here I can say PM networking, PM networking. Welcome to networking project, and after that we can change it, like we can say here a VLAN configuration. If you know the HTML coding, you can design the website. This is the website designing, right? OSPF protocol like this, and let's save it. Now guys, I have created one website here on this server, and let's try to access this website from this PC. So on the PC I can open any browser, and in the browser I can type the IP address of my website. See, if you want to access this website through domain name, then you have to configure the DNS. For now, the IP address of server 1 is, server 1 belongs to VLAN 30, so IP address will be 30.1. So 192.168.30.1. And you can see that I have access of website, VLAN configuration, OSPF protocol, these things like the designing of website. Okay. So that's all for today, guys. Today what we have seen, how to create one project for college. This is perfect video for the beginner students who want to learn the networking, who is trying to make their career in networking, right? Now if you have learned something from this video, please hit on like button. If you have any query, concern, please let me know in the comment section. If you want video on any other topic, please let me know in the chat. Just put your topic in the comment section. I will try to make it as soon as possible. If you need part 2 of this video where users should be able to access internet, then also let me know in the comment section. That's all for today, guys. The last thing is, if you want to appreciate, please type yes in the chat. That's all for today. Thanks for watching. Bye bye.